Hey everyone, this is AZ, your Delta Lake fellow architect, and today we're getting into the Delta Lake Quick Start. Now, it's important to know that the topics covered here are a detail of exactly what's in the Git repo in the Quick Start. Anytime you come to a repo, you start from the README, you get a sense of what's there, what you're doing, what's coming. Now, this is very important. We're actually going to do all this. This is what we're going to do in the Colab notebook because it has the benefit of not requiring the environment and all that. You should also know that we are doing exactly what the Delta Lake documentation is telling us to do. But again, we're doing it in the simplicity of a Colab where we can start directly and not have to worry about environment and details. Now, who is the audience for this course? The audience for this course is anyone with an interest in computer science or a computer science student. The audience includes any business leaders or members who are on the product side or the project management or operations side, or leaders who want to know the benefits that Delta Lake can bring us and how simple it is to achieve those benefits. All right, so without further ado, the pip install, the important thing to know about the pip install, the pip command, is that this is a package manager. We'll be putting shell commands through via the Python interpreter. And how do we do that? That is the exclamation command. So all the explanations are above, but we're just getting started and we're doing our thing. All right, PySpark. PySpark is the Python interface for Apache Spark. And Apache Spark is a unified analytics engine for large-scale data processing. Keep in mind, PySpark, which is the Apache Spark, and Delta Spark, which is the Delta Lake library. It's an open source storage layer that brings reliability to data lakes. These two together are co-working, and that's where the strength lies of what we're in the process of building. Here you see some output commands, and then we are on to the next segment. Importing libraries. Now, these code segments are explained above. This code imports the required libraries for working with Apache Spark and Delta Lake. Specifically, it imports PySpark SQL, imports Spark Session. The Spark Session class from the PySpark.sql module gets imported from this command, and Spark Session is the entry point for creating a Spark application and interacting with Spark's functionality. From Delta Lake import star. This line imports all functions and classes from the Delta Lake module, which is part of the Delta Lake library. This library provides utilities for working with Delta Lake, which is a storage layer that brings ACID transactions, scalability and performance to data lakes. ACID transactions are important. We'll be getting into those. Excuse me. By importing these libraries, you gain access to the necessary classes and functions for creating Spark sessions, reading and writing data, and interacting with Delta Lake. All right, so creating a Spark session with Delta Lake. This code creates a Spark session and configures it to work with Delta Lake. And the steps: create a Spark session builder. This builder Spark session builder, builder equals command is in effect launching this function with the name Delta Lake Quick Start. This line creates a Spark session builder with the application name set to Delta Lake Quick Start. Configure. So this line build config is configuring a Spark session for Delta Lake. This line adds a configuration to the Spark session builder, enabling the Delta Lake SQL extension. Then we have Spark config SQL catalog. Both this line configures the Spark session to use the Delta Lake catalog for managing tables and databases. Lastly, we have the Spark configure. Configure Spark with Delta pip builder, get or create. This line creates and configures the Spark session using the config Spark with Delta pip function from the Delta Lake library. And then the get or create method creates a new Spark session or returns an existing one if it has already been created. By configuring the Spark session with Delta Lake extensions and catalog, you enable Delta Lake capabilities within your Spark application. This includes features like ACID transactions, data versioning, and improved performance for Data Lake workloads. Creating a Delta table. This code creates a Delta table using Apache Spark and the Delta Lake library. Data equals Spark range 05. This line creates a data frame named data containing a range of integers from 0 to 4 inclusive. Notice that 5 is not included, it's from 0 to 4. Using the Spark range function. So the range ends just before the next number that's specified. The data write format, this function, basically this line writes the data frame to a delta table located at, temp delta table, that path. The write method is used to initiate the writing process. Format delta specifies that the data should be written in the Delta Lake format. Mode overwrite sets the write mode to overwrite, which means that any existing data in the delta table will be replaced by the new data. And then save temp delta table saves the data to the specified path, creating a new delta table or overwriting an existing one. The resulting delta table will be stored in the temp delta table directory, and it will contain the integer values from 0 to 4. Delta Lake tables provide additional features like ACID transactions, data versioning, efficient data storage and retrieval compared to traditional file-based data lakes. All right, reading from the delta table. This code reads from the previously created delta table and displays the contents. Now the steps are, we read from the delta table, df equals spark read format delta load command. This line reads data from the delta table located at temp delta table. The read command, the read method is used to initiate the reading process. Format delta specifies that the data should be read from a Delta Lake table, and then load, temp delta table loads the data from the specified path, which contains the delta table. The resulting data is stored in the df data frame. Therefore, when we say df show, this displays the data frame contents. This line prints the contents of the df data frame to the console or notebook output. By reading data from the Delta table, you can leverage the features provided by Delta Lake, such as data versioning and efficient data retrieval. The show, whenever we say a function, we don't say open and close parentheses. That's just understood. So you kind of get used to that. The show method allows you to inspect the contents of the data frame, ensuring that the data was read correctly from the Delta table. And this is the output of the show function, of the show call, right? So order doesn't matter here. So this is the values, basically what you wrote into, this is what you have read in that range that you specified. All right, update the delta table. All right, so now this code updates the existing delta table by overwriting it with new data. First thing we're going to do is generate new sample data. So we're going to say, hey, the range, our data range, right? This line creates a new data frame named data at, containing a range of integers from 5 through 9 inclusive, right? In fact, when we say 5 through 9 inclusive means not counting 10. So 5 to 10 exclusive or 5 to 9 inclusive. And we do this using the spark.range function. And when we read this, you're going to hear me say spark range. You're going to hear me say data write format. We don't typically say the dots. You can sort of get used to that talking to techies. All right. Overwriting delta table with new data. Now here, data write format delta, mode overwrite, overwrite, save temp delta table. This line overwrites the existing delta table located at temp delta table with the new data frame. The write method is used to initiate the writing process. The format delta specifies that the data should be written in the Delta Lake format. Mode overwrite sets the write mode to overwrite, which means that any existing data in the delta table will be replaced by the new data. And then the save temp delta table saves the new data to the specified path, overwriting the existing delta table. And the df show, right? Df show, you know what it does, so I'm not going to repeat that. After executing the code, the delta table at this path will no longer contain the original range that we had from 0 to 4 inclusive. Instead, it'll be overwritten with the new range of integers from 5 through 9 inclusive. And here is the output of the df show. And notice that we're saying this. We say this for our own benefit, right? Print is a basic statement. I didn't care to expand it, but you guys should know this prints this message, and this df show essentially prints the contents of the data frame. All right, so read updated delta table. How are we doing so far? This is fun, right? Simple. It's so simple. All right, reading the updated delta table. This code reads the updated delta table and displays its contents. Now the steps. First, we read the df spark read format. So we read. Here, the data is read, this line reads data from the updated delta table, which we just updated above. And then the read method is used to initiate the reading process. Format delta specifies that the data should be read from a Delta Lake table, and then the load. I didn't say this. This should be pretty self-explanatory. Spark means that we're executing a Spark method, right? Shouldn't be too complicated there. But if there are questions that I leave unanswered, I expect you to please respond, interact, and they'll be explained. And it would be very appreciative, very much appreciated. And I would be very appreciative of anyone responding with, hey, you did this, but you didn't explain that. So allow me to meet the needs of my audience. And the audience is basically anyone. Even people who are not from the technology background and trying to step into the tech background, because Delta Lake with Apache PySpark really makes it very simple. All right, we did the df, we did the show, and we are now in, you've seen the output. Now, having seen the output, you know that conditional updates without overwrite data lake programming. Actually, okay, you don't know this. So if we do output but do not overwrite Delta Lake, we have a programmatic API to conditionally update, delete, and merge, which is called upsert, update, delete, update and merge, or update and insert combined. It enables us to do that with data. And then a few examples. All right, so now we're getting into this one. Seems a bit scarier, but honestly, it is very simple, and it will accomplish some very simple things. And once you see this, you will know that it really is simplicity itself. So this code demonstrates various operations that can be performed on a delta table, such as updating, deleting, and upserting, which is update and insert. Upserting data. It showcases the use of Delta Table, the use of the Delta Table API provided by the Delta Lake library. Imports. From Delta Table, import star. So this line imports the necessary classes and functions from the Delta Tables module, which is provided in the Delta Table API. Then from PySpark SQL functions, import star. This line imports various functions from the PySpark SQL functions module, which are used for performing data transformations and manipulations. All right. Now, what are the steps? We first do delta table or path, right? What does this accomplish for us? This line creates a delta table object, it creates a delta table object, delta table. This is the object, this is the class, right? So we're creating an object of this class, and we do this by pointing to the existing delta table located at delta table, right? So we then are doing an update. So to update values, let's say we give ourselves a conditional situation where we only want to update every even numbered value, to the 0th, the 2nd, 4th. Don't know if we'll have a 0th value. Depends on the data, right? Actually, that's a trick question. Computer science begins with 0. So the first number is 0. All right. Um, so delta table update, and then the condition expr, and then the details of the condition. This line updates the delta table by adding 100 to the ID column for all rows where the ID is even. All right. Um, the update, now in this case, ID is a self-chosen column. It's our defined column. Um, and these are key value pairs, right? So the value for that, okay. So the update method is used to perform the update operation. Condition equals expression, and then in quotes, ID divided by 2 gives a result of 0, specifies the condition for which rows should be updated, which in this case is rows where the ID is even, right? That's how we're determining that this is an even even ID, and the fact that there's a 0 remainder, right? When we divide, there is no remainder. This is a mathematical operation or a Boolean operation, but the result is true or false. And if it's true, then the conditional expression is, then the condition is activated, right? So it defines the update. This row, this set defines the update expression, which adds 100 to the ID column, right? So it says set this to the output of this. All right, now we're going to do an upsert. Now, an upsert has the advantage of, let's say you're doing an insert and, an add, or a delete and add. And halfway down your process, your, power goes out, or systems crash, or there's an error. You now have to deal with rolling back the part that was done and ensuring that consistency is maintained. The upsert takes care of all of that. As a one-time database admin, believe me, I'm wishing this command was there over a decade ago or much longer. All right, so upsert or merge. We get excited, us techies. Oh man, where was this when I was learning this stuff? All right, so the delta table delete condition. Excuse me, delta table delete. Here we go, delta table delete condition. Here we go. So I was a bit further ahead in my excitement. So we're first doing a delete. All right, what's delete? Taking data away. Delta table delete, and then the condition, and then the value of the expression. This line deletes all rows from the delta table where the ID is even. All right, so the delete method is used to perform the deletion operation, and the condition specifies the condition for which rows should be deleted. In this case, rows where the ID is even. All right, now we get to the upsert and the goodies of upsert. All right, so new data is Spark range 20. So we're first saying this line creates a new data frame, new data, containing a range of integers from 0 to 19, right? So 0 to 20 exclusive, or 0 to 19 inclusive. Delta table alias. Well, we'll get to that. We're doing a new data show. The new data show is is basically showing us what we have so far. So here's what we have, and the output of that first delta show. For that, we're also saying print. Actually, this is new data. Here we go. Where's our show? Yeah, that's where we are. So here we are saying show data frame new data. That's this right here. And then we're showing what the new data is. So all we did in this upsert is we set this value, and we're saying, all right, we start from here. We're starting from values going from 0 through to 19. That's what we accomplished right here. Now from here, we're going to do a print show table after update, right? So we're going to show table after update, and then what's the the next command here, delta table 2df show. All right. So delta table 2df show. This line converts the delta table object to a Spark data frame using 2df, this 2df show, and displays its contents using the show method. All right. So after the update, when we're doing the show, what are we seeing? We are showing the table after the update. 789, excuse me, wait a minute. After the update shows upserted. Yep, that is it. So print delta, yeah. So by executing this code, you will see the delta table being updated, deleted, and merged with new data. Wait, I didn't skip anything yet, right? Wait a minute. 2.show, to show. No, I think I might have. Yes. Delta table to show. We did the delete. All right. Old data. We have for every data table, delta every even value, delete every even value, upsert. All right. So we've extended the range, show data frame, new data. This is the new data, which is this right here. Then from there, we go show table after update, and then delta table 2df show data. Delta table 2df show data. Delta table update, delta table 2df. Yep, it's right here. Delta table 2df show data. Here we go. This line converts the delta object to a Spark frame using, yep, that's correct, and displays its content using the show method. Exactly, that is it. That's this right here. All right, and that is what we are seeing here. Show table after update. Show table after update. Now, the next part, the last part, that is delta table alias. Let's pull up the, okay, we can't, it's just limited space. Delta table alias. All right, so this is an upsert. Delta table alias is merge new data. Yes, so this new data Spark range 20, that is part of this here. Yes, show table after show, we've done that. We have delta table alias old data. This block of code, got it. Delta table alias old data, gotcha. All right, so this block of code performs an upsert, a merge operation from the delta table, merging the new data frame with the existing data. All right, the alias method is used to assign aliases to the delta table. Old data, let's see, old data right here, right? To the new data, which is new data, all right? So we're calling it new data, and it's assigning the, exactly, aliases to the delta table old data. And so we're assigning new data this, and old data is new data.id, correct. The merge method is here. The merge method initiates the merge operation, comparing the ID column from both datasets. We use upsert method, which combines an insert with an update operation to improve data integrity and simplify any potential rollback. For additional documentation on the upsert method, you can refer to the Delta Lake documentation. This is right here. So there is an update that needs to come further up, which we will take care of. Here is a Delta Lake documentation, and you can read about upsert into tables and all the details thereof. So, yep, modify. So it's pretty simple for people who want details, but the details are right there. So this is where you go for additional documentation. Alrighty, and having done that, delta table, so we start from here. Maybe I shouldn't be scrolling, right? I'm mixing myself up, and I'm hopeful that I'm not making it difficult for my audience. I hope you have the same screen open on the side. So even with me going up and down, you know that we're right there. All right, so the print. We did the print show after the update. Yeah, we were looking at the delta table alias, exactly. The merge. We just explained the merge. All right, when matched update. All right, so now the next row. So you should also know a dot this is the entire command. So we use this method where when a parenthesis opens and it closes, I should have explained this at the start. From an opening of a parenthesis to the close of a parenthesis, it's essentially, you can read it as a single line, or that dot tells us this, that in this method, we're calling this, sorry, in this class, we're calling this method and doing this to it, and this is the name of it. So this becomes the object. And this entire line is more easy to read when we write it in this way. So even though it's, it's a single function call, you can consider it as, but writing it like this just makes it easy to read. So now we're going to the next row. Okay, when matched update. So when matched update specifies the update logic when a new row in old data matches a row in new data, right? So when so we have the the logic there, and then when not matched insert specifies the insert logic when a row in new data does not match any row in old data. And then the execute method finalizes and applies the merge operation in the delta table. So that hopefully was pretty simple. I mean, if you just read it as, all right, it's a merge, then a when matched update, then a when not matched insert, and then execute. And then the details for merge are in there. When matched update, the details are there. So basically, we could just read, what we did is we did an import, from somewhere. We did an import, we did another import. Then we specified essentially what the table is, and we updated every value by adding 100 to it. Then we updated every even value by adding 100 to it. We deleted every even value. We upserted. We did um, you know, to do the upsert, we started with a new range, right? The upsert didn't end here. This entire remainder is the upsert. And then we printed what the value is after the update. So what I've done is, since I've run the code before, you see data in there. But the first time you're running it, your output will be simple. And then here we are doing a merge, right? So we set the alias, we're doing a merge. We say when the updates, when the IDs match, and then when the IDs don't match, after specifying all that, we execute. Here's where everything is run. And now the print show upserted is basically our message, and that's what we're going to see down here, right? We see the message first and then the output, which is the delta table 2df show. This line converts the delta table object to a Spark data frame using 2df and displays the content using the show method. Now, by executing this code, you will see the delta table being updated, deleted, and merged with new data. The final state of the delta table will be displayed, reflecting the changes made through these operations. How about we end this recording here and we resume with querying a specific version of the Delta Lake. Thanks, everyone. It's a pleasure working with you and looking forward to continuing. Thank you.